Thanks. Sorry. So I'll be talking about Exotic today, which is our EXOplanet transit interpretation code, which is a Python 3 package that will work on any time series photometry for observing transits. But just to give some context for that code, I'll be quickly talking about EXOplanet Watch and setting up why we have this code at all. So I am the project lead of EXOplanet Watch, which is the citizen science project to observe transiting exoplanets. And I'm at NASA's Jet Propulsion Laboratory out here in Los Angeles. And as you're all aware, we're observing many interesting planets using the transit method to characterize the atmospheres of these planets, either with Hubble or James Webb, or with any ground-based telescope. But in order to observe these transits with these large observatories, we have to know very precisely when these transits will occur. If there's any uncertainty in your transit times, that's additional observational overhead you need to build into your campaign, which at the end of the day is not an efficient use of these platforms, especially when you want to look at tens of planets, hundreds of planets with James Webb, or hundreds or thousands of planets with the European Space Agency Ariel mission, which is launching at the end of the decade. So we've launched this project to help out NASA missions and efforts to routinely observe transiting exoplanets to keep their transit times precise. And this involves not only professional astronomers and their data, but also amateur astronomers across the world. Quite simply, because these amateurs are able to achieve excellent data quality, and there's too many planets for all of us professional astronomers to keep up with. And by working on targets that are big, that are bright with amateur astronomers, we can then use larger professional telescopes to go after dimmer targets with smaller transit depths. EXOplanet Watch is a collaborative effort to complement existing surveys. We have a great working relationship with EXOClock, which is doing refinement of the ephemerides for the Ariel mission. And I think they've already saved a few hours for Ariel, which is awesome. And we've worked on a few campaigns with them as well. So we're really happy to continue working with them as well. All of our data is immediately public. There's no proprietary phase. We update our database every other night. So you can go on our website right now and you can write your own papers using our data or our data products. Just cite our paper and give us an acknowledgement. As I mentioned, we have target requests by professional astronomers. We actually had two campaigns back at the end of 2021 that were just published in November and December of 2022. We ended up saving about 3 to 5 hours of James Webb time, and we're in a great spot to help support any current or near future observations with any telescope at all. We can do ephemeris maintenance, but we can also do stellar variability monitoring as well and help determine if variability of the host star impacts your transit measurements at all. All of our observers are listed as co-authors. If they do the work, they deserve the credit, and we're funded through the end of 2026, at the very least, by NASA's Universe of Learning. As a citizen science project, we both have educational goals and science goals. The science goals I mentioned, it's mostly that ephemeris maintenance and working with other groups such as TFOP, SG1, working at the Single Transitors Group, and having this excellent collaboration with the EXOClock folks in Angeles and his team. To discover and confirm new exoplanets, monitor for stellar variability. And we also have these educational goals, which at the end of the day really is inspiring the next generation of astronomers to join, hopefully, astronomy or other STEM fields. So if you're interested in joining our project, here's a quick little roadmap to our user experience. It's a little overwhelming, so I'll step through it super quickly and then talk about Exotic, our data reduction code. If you have your own telescope, you can plan your own observations. We have a little insert on our website with the Swathmore Transit Finder. They very kindly have hosted our target list up there. And you can observe that. If you have your own telescope, you can observe our recommended targets. You can also observe whatever target you want. We'll accept any data on any target. So if you're at a university that has its own telescope or you want to get into observing, you can do that. And we're finding that users with scopes as small as 3.5 inches are able to get science-grade impactful data, even from areas like Los Angeles. So you don't need to be in a dark sky location and you don't need a big telescope. If you don't have your own data, you can request it through our data checkup system. We have about 10 years of archival data from the Micro Observatory, a 6-inch scope run by Harvard CFA out in Tucson, and they've very kindly donated 2,000 data sets to us, which we're making available to our users. So you can actually just fill a little CAPTCHA. You'll get an email automated back to you with your data set, so you can actually fully participate in this project as well. Then you analyze your own data. I'll talk about Exotic in a minute. You can use hops from ExoWorld Spies from ExoClock. You can also use Astro Image Day. It doesn't matter. Use whatever you want or are comfortable using. Just upload it in the right format to the AAVSO's EXOplanet database so it can be ingested into our pipeline. Then you sit back, relax, maybe crack open a beer to celebrate and get published or publish your own data. So I talked really quickly about Exotic. This is our EXOplanet transit interpretation code. This is our Python transit reduction tool. This runs on any platform, Windows, Mac, Linux machines. You can install it via pip. We also have it, the full repo on GitHub. The link is at the bottom of this page. Also, you can run this fully in the Google Colab Cloud Notebook. So you don't need to actually install any software locally on your own machine. You can actually just run it completely in the cloud for free on the Google Colab. So you can actually fully participate in this project by running the software on your smartphone, which is really helpful for folks who have an issue with, perhaps having an older computer or don't know how to install all the Python dependencies. That being said, Exotic is being used by tons of folks across the world, from high school up to professionals that have used it for tests, light curve fitting, for example. We use Pi Light Curve, which we are really huge cheerleaders for. We love using that, and LDTK. And as a result, by using these tools, by using a nested sampler fitter, we're actually able to do a full statistical fit to the data and fully reduce multi-object photometry in as little as about 5 to 10 minutes. It figures out your best comp stars, it checks for stellar variability on your comp or your target, it does the sky annulus, it does the Gaussian fitting of the PSF and also aperture fitting, and it figures out the best combination of parameters and inputs to give you that final science grade light curve at the end of the day. We also publish full posteriors, so you can just literally drag and drop these PDFs directly into your papers and not have to struggle with the data analysis. We try to make it as simple as possible so you can go from your raw data to publish results and write those papers. We also have this cool real-time data analysis tool. So if you're at a star party or observing at Palomar or any other observatory, you can actually do a really quick and dirty reduction of your data in real time to confirm that you're actually observing what you think. I literally use this all the time to make sure we're observing the transit object that we want and make sure that we're getting it at the right time at other telescopes. This also produces a text file automatically that you need to upload to our project. I'm getting a little short on time, so I'll quickly run through what happens in the back end of our project. We have this pipeline called Citizens. It goes out and scrapes all the data from the AAVSO EXOplanet database. We reprocess all the data and refit the time series with a slightly tweaked version of Exotic that just is just in case any priors change, and then we immediately publish them to our website as well. We've had this very successful observing campaign back in December, where we observed a target for James Webb. We ended up saving about 2 to 3 hours of James Webb time, and we were actually able to achieve a precision that got us matched or actually exceeded in some cases the precision of prior TESS observations. So TESS is doing an amazing job of getting high precision photometry and time series, but TESS can't look everywhere all at once, and that's where we hope to fill in the gaps and to get more data on these targets. We had over 24 facilities, all less than 0.7 meters, and I see there's actually a 1 meter scope on this list as well. And we probably had another 30 to 40 observers that wanted to participate, but there's clouds in most of the northern hemisphere. So this really shows why a large community like EXOClock, like Las Cumbres Observatory, like us, is necessary to overcome issues due to weather, but also the real big power in strength in numbers. You can bin multiple data sets from multiple telescopes together to achieve very high precision and science impactful precision. So if you're interested in joining our collaboration, you can scan that QR code on the left. If you'd like to take a look at the Colab notebook, which is really the recommended way because it's just so much easier to use, you can scan the QR code in the middle, and that's for the Colab notebook on Google Chrome. And that is literally the same exact code as we run on the back end for the Exotic GitHub. So you can install Exotic locally as well. You can run it from the terminal or from a GUI through Tkinter. So happy to take any questions. Thanks for your time.
Thank you, Rob. Very good presentation. Is there any question for Rob? Alexi, I think. You are muted, Alexi.
I think Alexis they might have put their.
Okay, sorry. Avi has a question.
Well, Rob, first of all, great talk and absolutely fantastic, organization, and just the tools you've put together are just really amazing. I have a question that's not exactly related to what your current, mission and focus is on the transits. I actually have a question about secondary eclipses. Um, and the reason I mention it is because oftentimes transits are detected in the visible light of interesting planets. And then we want to go observe maybe a secondary eclipse with JWST with a minimum amount of observing time. But we don't, because the orbital parameters are not very well known, if it has an eccentricity that's non-zero in some way or some we know it's very challenging to predict the timing of the secondary eclipse. Now, the hard part is secondary eclipses are mostly detected in the infrared. And of course, the cooler the planet, the farther in the infrared. Is there any sort of plan afoot or strategy, related to what you guys are doing that could help? From the ground, infrared measurements are harder, often require bigger telescopes and things like this. But is there something else that you can imagine that could, from your network or something else, help to improve in that area?
Yeah, totally. So that's literally what we did for the HD 80606 paper that Kyle Pearson published in November of 2022. So we actually saved the most amount of time we saved was on the eclipse observations, 806, and we saved 2 to 3 hours because Kyle combined not only the test data and our network of users' data, but also radial velocity data as well to nail down that eclipse time. So yeah, we're actually chatting with Jen Burt on identifying some really targets that have very high uncertainties in the eclipse times, and then see if we can get RV data on there. So if any of you would like to work or collaborate or have target suggestions, please do reach out to me. I'm on the Slack channel for EMAC, and then also we have a really friendly Slack channel for the project as well.
Cool, thank you.